do the numbers really matter? In chemistry, always. I'm Matt Queen, and this is Significant Figures, Precision and Accuracy. Chemistry is involved in all sorts of things that run the spectrum from cooking pasta sauce to making pharmaceuticals for babies. You might imagine that attention to detail is a little less important in grandma's pasta sauce. That might depend on your grandma. So I've been practicing my axe throwing. The name of the game in axe throwing is to hit the bullseye. That's accuracy. Now, both of these sets of throws are accurate, while these two are not. Let's look at the difference between the two accurate ones. The axes on the left are all spread out evenly around the middle. If we were to average them, we'd get a bullseye. These ones on the right are far less spread out. You could say that they're more precise or reproducible. You can also be precise and not accurate. I am often neither, top left. We've secured a highly accurate 20-gram standard here that must be handled with the utmost of care. Now, I'm going to wear these lint-free gloves to keep myself from imparting any sort of hand oils onto them accidentally. Let's take a look at our standard. Oh, good. We've secured another highly accurate 20-gram standard. Let's place it on this kitchen scale. Now, it gives the mass as 20 grams. This scale is fairly accurate, but I can only give the mass to two significant figures, as the precision of the scale is just that. So we don't know if it's maybe 19.6 grams or 20.4 grams. Both of these would give 20 grams on this scale. Now, let's weigh this standard using two decimal place balance. It says that the mass is 19.97 grams. This is more precise because it gives the mass to four significant figures. We can tell that it is not 19.6 or 20.4 grams. Finally, let's use this high precision balance. It gives the mass to four decimal places. We see that the mass is 21.0002 grams. This is very precise at six significant figures, but we can tell that it is inaccurate. Anytime you use a piece of equipment, you need to be sure that it is calibrated using a high accuracy standard. Now, I've taken the time to calibrate this balance, and it shows the mass to be 20.0002 grams. Now we have precision and accuracy. We can also measure volume in the lab using things like this beaker, a graduated cylinder, or even a volumetric flask. Let's see how each of these does, measuring out 25 milliliters. In order to check their accuracy and precision, we're going to use this high precision standardized balance. Based on the density of water, 25 milliliters should weigh 25 grams. Let's add 25 mils of water. There's a line right at 25 milliliters. I did this earlier for 3 different samples. We can see how much the numbers vary, and they vary quite a bit. The cup is not very precise. The best we can do is say that this measures about 25 milliliters. Let's now use the graduated cylinder. Notice that the column of water is narrow, and we can see the meniscus, the curvature of the surface of the water. You should always use the bottom of the meniscus and line it up so that you can read it straight on. Again, I took the mass 3 times. and got these data. They're closer to each other, but still, the best we can do is say that the cylinder measures 25 milliliters. But we cannot get more precise than that. Now, the volumetric flask. This is a $1 piece of glass with a $20 line drawn on it. What do I mean by that? Well, notice that the label says plus or minus 0.01 milliliters. That tells us that this piece of glassware holds 25.00 milliliters accurately, and that our results should be plus or minus 0.01 mils of precision. Now, look at these numbers. We can certainly say 25.0, and we can even go to 2 decimal places, 25.00 plus or minus 0.01. The volumetric flask is much more precise than the other two. So, if you're making pasta sauce with grandma, feel free to use less precise instrumentation. The little differences won't matter. But if you're making drugs for babies, a little difference can mean life or death. You're going to want to make sure that you get it absolutely right. So make sure your instrumentation has the utmost in precision and accuracy. So, there you have it.